In this video, I'm going to explain the IDFT computations using DIT FFT algorithm. First, I'm going to define the DFT, that x of k is equal to summation n is equal to 0 to n minus 1 x of n into e power minus j 2 pi k n by n. Here, x of n of DFT will give x of k. Now, I am selecting that IDFT representation x of n is equal to summation k is equal to 0 to n minus 1 x of k into e power j 2 pi k n by n into 1 by n. Now, even in this formula, I can just do the cross multiplication with this n, and I am representing n into x of n, that is equal to summation k is equal to 0 to n minus 1 x of k into e power j 2 pi k n by n. So now, when you are comparing this equation with this one, and here the input term is n into, input term is x of k. X of k of IDFT is giving us n into x of n. Now, to use the same butterfly diagram, I'm just comparing this to this part, that is summation and the summation, both are matching. This x of n is sequence, this x of k is also sequence, no problem. But here we have one minus sign, e power minus, but here the minus is missing. So to use the same butterfly diagram, to generate the minus, I am selecting the conjugate for the entire equation. So I am selecting the whole conjugate for this equation. So now this is n into x star of n is equal to summation k is equal to 0 to n minus 1 x star of k into e power minus j 2 pi k n by n. So now when you are comparing this first equation with the second equation, both the equations right sides are similar. So this is summation representation, sequence, sequence. E power minus j 2 pi k n by n, e power minus j 2 pi k n by n. So both are similar, so we can use the same butterfly diagram. But actually in the first equation, the input is x of n. In the first equation, the input is x of n. But in this equation, the input is x star of k. So to use a butterfly diagram, we are going to select x star of k, and from the butterfly diagram, we have get the output is n into x star of n. From that n into x star of n, we can easily identify what is x of n. That steps only we are going to do it here. So the first step for performing IDFT is we need to find x star of k. So I am just taking x star of k. So x star of k is equal to 36 minus 4 minus 9.656j minus 4 minus 4j minus 4 minus 1.656j minus 4 minus 4 plus 1.656j minus 4 plus 4j minus 4 plus 9.656j. So we selected the conjugate representation for the input. For performing DIT FFT algorithm, the inputs are bit reversed order. So I am going to represent the bit reversed input representation for the 8 point. So the bit reversed representations are x star of 0, x star of 4, x star of 2, x star of 6, x star of 1, x star of 5, x star of 3, and x star of 7. So in the previous video, I showed how to select that bit reversed order. Even we selected that input with x of n representation. Now the same structure, only thing is the input is replaced by x star. So we selected that input. Now I'm going to write the corresponding input value. So x star of 0, that value is equal to 36. X star of 4, I'm writing that values directly, that is x star of 1 is minus 4 minus 9.656j, that is for x star of 1. x star of 2 is minus 4 minus 4j, x star of 3 is minus 4 minus 1.656j, minus 4 minus 1.656j, and x star of 4 is minus 4 and x star of 5 is minus 4 plus 1.56. So minus 4 plus 1.656j, and x star of 6 is minus 4 plus 4j, and x star of 7 is minus 4 plus 9.656j. So we have got that 8 values, and now I'm going to perform 2-point DFTs, because for DIT algorithm, first the available inputs are divided into 2-point sequence, and from the 2-point sequence we need to calculate 2-point DFT. For performing 2-point DFT, in the top we are going to perform the addition, in the bottom we are going to perform the subtraction. So first I'm going to add the first two values and I'm going to represent that is in the top. So 36 minus 4, so that is equal to 32. In the bottom I'm going to represent the subtraction. So 36 minus of minus 4, that will become 36 plus 4, so we got the value is 40. And the next time, for the next 2 points, again we are going to generate 2-point DFT. The top we are going to perform the addition. So minus 4 minus 4j plus minus 4 plus 4j, so that will become minus 8. In the bottom we are going to perform the subtraction. So minus 4 minus 4j plus 4 minus 4j, so you will get minus 8j. Same thing we are going to do it for the bottom 2. The next 2-point sequence, so the top we are going to perform the addition, minus 4 minus 9.656j plus minus 4 plus 1.656j. So when you are adding both, you are getting the value is minus 8 minus 8j. And now the next you are going to perform the subtraction, minus 4 minus j 9.656 and minus 4 minus of minus 4 plus 1.656j. So you will get the value is minus 11.312j. And the last 2 points we are going to add the top to perform 2-point DFT, that is minus 8 plus 8j. In the bottom, in the subtraction results, we will get it as minus 11.312j. So the 2-point computations are over. We are going to combine two 2-point DFTs and we are going to generate 4 points. Before that, the second grouping must be multiplied with Tudin factor. So I'm going to multiply this with W4 power 0 and this one is W4 power 1. Anything power 0 is 1 and W4 power 1 value in the previous video we calculated, that is equal to minus j, and I'm going to perform this multiplication. So minus 8 into 1 we will get it as minus 8 and minus 8j plus 4 plus minus 8j into minus j, so minus into minus plus, j square value is minus 1, so you will get it again minus 8. So we have the value 32, 40, minus 8 and minus 8. So now we can perform the addition. The first two values are going to be added with second two value on the top. So 32 minus 8, so that will be 24. 40 minus 8, that is equal to 32. Now we are going to perform the subtraction on the bottom. 32 minus of minus 8, that is plus 8. So 32 plus 8 is 40. And 40 minus of minus 8, so it is 48 now. So the first 4-point DFT is over. The second 4-point DFT is we are going to select the bottom 4. In that the second 2 will be multiplied with the W4 power 0 and W4 power 1. The W4 power 0 value is 1, W4 power 1 value is minus 3. This already we calculated in the previous video itself. Now to perform this 4-point DFT, the top we are going to perform this addition. Before that I am writing the values, minus 8 minus 8j minus 11.312j. And when you are multiplying a minus 8 plus 8j with 1, you will get minus 8 plus 8j. When you are multiplying minus 11.312j with minus j, minus into minus plus, and j square value is minus 1. So you will get the value is minus 11.312. So now again in the top for calculating 4-point DFT, we are going to perform this addition. So minus 8 minus 8j plus minus 8 plus 8j. So that is equal to minus 16. And the next one, minus 11.312 plus minus 11.312j. So that is equal to minus 11.312 minus 11.312j. And then that bottom, we are going to perform the subtraction. So minus 8 minus 8j minus 8 minus plus 8j, we are going to perform the subtraction. So this will be minus 16j. Again, we are going to perform the subtraction for the last two. We will get 11.312 minus j 11.312 or minus 11.312j. So now we have calculated 4-point DFTs. To perform 8-point DFT, that second group, that is second 4-point DFT must be multiplied with the Tudel factor. So I am going to multiply that with W8 power 0, W8 power 1, W8 power 2 and W8 power 3. And I already calculated these values in the previous videos. I am directly writing the answer. W8 power 0 value is 1. W8 power 1 value is 0.707 minus J 0.707. W8 power 2 value is minus J. W8 power 3 value is minus 0.707 minus J 0.707. So now perform this multiplication with the Tudel factor and I am writing the values here. So minus 16 into 1 minus 16 minus 11.312 minus 11.312j into 0.707 minus 0.707. When you are performing that multiplication, I am getting the answer is minus 15.999 and no imaginary term. Minus 15.9999. So I am considering that is minus 16. And again that next one, minus 16j into minus j. So minus into minus plus, j square value is minus. So that will become minus 16 again in the last, when you are multiplying 11.312 minus 11.312j with minus 0.707 minus 0.707j, you will get it as minus 15.999. Again, no imaginary term. So I am just substituting that is also 16. And the top four values are 24, 32, 40 and 48. So now performing the 8-point, the first four samples are going to be added with the second four values and the first four values are going to be subtracted with the second four values. So we are going to do that for calculating 8-point DFT. So 24 minus 16, we will get 8. 32 minus 16, we will get 16. 40 minus 16, we are getting 24. 48 minus 16, we are getting 32. And now we are going to perform this subtraction. So 24 minus of minus 16. So that will be plus 16. So this will become 40. 32 minus of minus 16. So that will become 32 plus 16. That is 48. And then 40 minus of minus 16. That is equal to 56. And finally 48 minus of minus 16. That is equal to 64. So we have got this answer. And in the beginning, we expressed that input x star of k from the butterfly diagram. We are going to calculate, but from the butterfly diagram, we will find n into x star of n. So your available answer is n into x star of n. So I am going to write the answer n into x star of n. That is equal to, the first value we got it as 8, 16, 24, 32, 40, 48, 56, 64. Now, the n is the fundamental time period. Here, the repetition period is 8. So, I can select that n is 8. So, x star of n is equal to 1 by n into 8, 16, 24, 32, 40, 48, 56, 64. Since n is 8, I am going to substitute that 8 here. So 8, 16, 24, 32, 40, 48, 56, 64. So when you are dividing with 8, you will get 1, 2, 3, 4, 5, 6, 7 and 8. So this is for x star of n. So what is x of n? So if there is any imaginary terms, we can represent the conjugate, but there is no imaginary term. So we can write that values as it is 1, 2, 3, 4, 5, 6, 7, 8. So we have got IDFT with the help of DIT FFT algorithm. So for DIT FFT algorithm is initially we are dividing the sequence into 2 points. 2 points to 2 point DFT computed, 2 point DFTs to 4 point DFTs are computed, and 4 point DFT to 8 point is calculated. And initially we are just matching the direct computation DFT with IDFT formula. From that we are using the same butterfly diagram even for identifying IDFT with the input representation x star of k and the output is n into x star of n. From that we can identify what is x of n. So I hope you are clear with that. Thank you.